Have you ever just stared at that shiny espresso machine on your counter and wondered what's really going on inside? Today, we're going to pop the hood and look at the core tech that separates, a decent coffee from a truly perfect cafe quality shot. Let's dive in. So, what is the secret to a truly perfect espresso? I mean, is it the beans, the grind, that special touch from the barista? Well, yeah, of course it's all of those things, but the machine itself, it plays this massive role that we often overlook. The secret isn't just one thing. It's more like a symphony of forces, all working together in perfect harmony. So we're going to follow the journey of water as it becomes espresso, and we're going to focus on three super critical stages, what I like to call the three pillars of extraction. You've got pressure, that's the force. Then temperature, which is all about the flavor, and finally delivery, the grand finish. Get these three right, and trust me, you are well on your way to greatness. Okay, first step, pressure. This is the raw brute force you need to push water through that tightly packed puck of coffee. Think about it. Without the right pressure, you simply can't extract all those delicious oils and sugars and amazing aromas that make espresso, well, espresso. So what's the magic number we're aiming for? Well, the industry standard, the absolute gold standard, is 9 bars of pressure. To put that in perspective, that's roughly 9 times the normal atmospheric pressure at sea level. That's the target. That's what every good espresso machine is trying to hit, and hit consistently. But how do these machines actually create and then maintain that pressure? It's not as simple as just turning on a tap, right? That's the all-important job of the pump. And in the world of espresso, there are really 2 main technologies competing for the top spot. And this right here reveals a really key trade-off when you're looking at machines. On one side, you've got the vibration pump. You'll find this in a lot of entry-level machines. It uses a little piston to create pressure in these quick pulses. That's where you get that characteristic loud buzzing sound. Then on the other side, you have the rotary pump. This is what you'll find in prosumer and commercial machines. It uses rotating gears for this super smooth, continuous pressure, and it's much, much quieter, more like a gentle hum. So here's the crucial takeaway, the thing you really gotta get. That pulsing action from a vibration pump, it can cause these tiny fluctuations in pressure. A rotary pump, on the other hand, delivers steady, completely uninterrupted pressure. And that stability is everything. Because if your pressure is inconsistent, you get uneven extraction. And that's how you end up with those dreaded sour or bitter flavors in your cup. Nobody wants that. All right, on to our second pillar. We've got the pressure sorted. Now we need to get that water to the absolute perfect temperature. And this isn't just about making the water hot, right? This is about precision. It's about unlocking this whole complex spectrum of flavors that are just hiding inside the coffee, waiting to come out. So the traditional way to do this is with a boiler, and you can pretty much just think of it as a small hot water tank living inside your machine. It heats up a whole reservoir of water, and it's fantastic for 2 things, providing a big, stable source of heat and delivering really powerful, consistent steam for froth in your milk. Now, the more modern alternative is something called a thermoblock. Instead of a big tank, water snakes its way through a series of heated tubes. It's basically a flash heating system. It only heats the water you need for that specific shot, right as it passes through. Kind of like an old radiator, but for coffee. And this is where you see the core trade-off, right? Thermal blocks are incredibly fast. They go from cold to brew ready in just a couple of minutes because they're heating so little water. Boilers, on the other hand, take way longer to heat up, but that big reserve of hot water gives them way more power and stamina for steaming milk, which is exactly why they're the go-to for busy cafes. Okay, so let's recap. We have perfectly pressurized water. We have perfectly heated water. The final pillar, the last step, is all about delivery. How do we get that water onto the coffee grounds in a controlled, stable, even way? Well, my friends, that is the job of the group head. And look, you absolutely cannot talk about group heads without talking about the legendary E61. Introduced by a company called Fema way back in 1961, it was a complete and total game changer. Before the E61, espresso machines were, well, they were pretty inconsistent. This single innovation brought a whole new level of temperature stability and control to the entire brewing process. It really changed everything. And one of its most important innovations was mastering something called pre-infusion. So here's how it works. The machine first introduces water at a really low pressure, like 2 to 4 bars, gently soaking the coffee puck. Why? It's all about making sure the grounds are evenly saturated before that full 9 bars of pressure comes blasting through. This one little step dramatically reduces the chances of water carving out little channels and causing an uneven extraction.
And the impact isn't just something you can taste, it's measurable. Yeah, studies have actually shown that proper pre-infusion improves the overall consistency of an espresso shot by about 15%. That is a huge reduction in off flavors, all thanks to that initial, gentle soak.
But that's not all. The other E61 superpower is its thermosiphon system. Now, this is a clever design that constantly circulates hot water from the boiler right through the massive heavy brass group head. And as you can see on this chart, this keeps the temperature incredibly stable right where it matters most, during the extraction. We're talking a variance of only plus or minus 1.5 degrees Celsius, compared to a potential 5-degree swing in other designs. That's a massive difference. So there we have it, our 3 pillars: stable pressure, stable temperature, and a controlled, even delivery. Now, let's just take a second and connect all this cool technology to the actual science of what's happening in your cup. Coffee scientists, they don't just guess about taste. They use a metric called extraction yield, or EY for short. And what it does is it quantifies how much of the actual coffee bean's mass, the solids, has been dissolved into the final drink. It's literally a way to put a number on taste. And through tons of research, the Specialty Coffee Association has identified what they call a golden range for this extraction yield, somewhere between 18 and 22%. If you fall below 18%, your coffee is under-extracted. It's going to taste sour. But if you go above 22%, it becomes over-extracted and tastes bitter and harsh. And this is where it all comes full circle. That stable pump pressure we talked about, that rock-solid temperature from the heating system, and that controlled, gentle delivery from the group head, all of these amazing technological elements are designed with one single goal in mind: to help you consistently hit that 18 to 22% sweet spot, shot after shot after shot. So the next time you go to pull a shot, you'll know exactly what's going on behind the scenes, the 3 pillars working in harmony. And you can ask yourself a new question. Is my machine built for the perfect shot? Does it have the stable pressure, the consistent heat, and the controlled delivery it needs to hit that perfect,